Look up at the night sky for a moment and try to feel what you are actually seeing. Not just stars, not just points of light, but distances so extreme that your mind quietly gives up trying to measure them. Every dot above you is a burning sun, many of them long dead by the time their light reaches your eyes, and still the universe keeps stretching farther, colder, and more unreachable with every passing second. Now imagine this strange thought. What if the universe is not just big, but actively built in a way that refuses to be crossed? Not because we lack technology, not because we lack courage, but because something inside the structure of reality itself quietly pushes back against the idea of expansion. We like to think of the future as a straight road forward, where enough intelligence eventually turns the impossible into engineering problems waiting to be solved. But space does not behave like a road. It behaves more like a trap that looks like freedom from a distance. The faster you try to move, the more the universe resists. The farther you try to reach, the more time bends, energy explodes in cost, and distance turns into something more like a wall than empty space. And here is where the story becomes unsettling in a very interesting way. Because every civilization that ever looks upward eventually asks the same question. If the universe is so vast, why does it feel like it is closing around us the more we try to touch it? Tonight we are going to follow that question all the way into the deepest limits of physics, where speed, time, energy, and expansion start behaving less like tools we can use and more like rules that quietly decide how far intelligence is ever allowed to go. People often imagine space as an open ocean waiting for humanity to spread across it, but the deeper physics reveals something far stranger. The universe may actually contain a hidden law that silently prevents civilizations from ever colonizing galaxies. At first glance, the stars seem reachable. We see rockets leaving Earth, probes crossing the solar system, and scientists discussing interstellar travel as if it is only a matter of engineering. But the terrifying truth is that the universe itself appears designed to resist expansion on galactic scales. The first barrier is the speed of light. Light travels at nearly 300,000 kilometers per second, fast enough to circle Earth 7 times in 1 second. Yet even at this unimaginable speed, space remains absurdly huge. The nearest star system, Alpha Centauri, is over 4 years away if you travel at light speed. Human beings cannot reach that speed because the laws of physics refuse to allow objects with mass to move that fast. The closer a spacecraft gets to light speed, the heavier it effectively becomes, demanding even more energy for every tiny increase in velocity. Eventually, the required energy approaches infinity. It is as though nature placed an invisible wall around every civilization and said, "You may dream of the stars, but you cannot truly reach them." EMC2, that equation looks innocent, but hidden inside it is one of the greatest traps in the universe. Energy and mass are deeply connected. To push a giant colony ship near light speed would require unimaginable energy, perhaps more than entire planets could generate over centuries. Every kilogram matters. Every additional passenger, machine, or food supply multiplies the problem. Science fiction often imagines enormous city-sized spacecraft traveling between stars, but physics treats those dreams brutally. The universe does not care about ambition. It only cares about energy balances. Even if humanity somehow solved the energy problem, time itself begins to behave strangely during relativistic travel. At extremely high speeds, time slows down for the travelers compared to people back on Earth. A crew might experience 10 years aboard a ship while centuries pass outside. Imagine leaving Earth to establish a distant colony, only to discover upon arrival that the civilization you left behind has evolved beyond recognition or vanished entirely. Space travel does not simply separate civilizations by distance. It separates them through time itself. Humanity may never spread as one united civilization because relativity breaks synchronization between worlds. T1 V2C2, the universe also hides another cruel detail. Space is not empty. People imagine a vacuum as harmless nothingness, but interstellar space is filled with radiation, magnetic fields, rogue particles, and microscopic dust grains moving at enormous velocities. At relativistic speeds, even a grain of dust becomes a bullet with explosive force. A tiny collision could release energy comparable to bombs. Over journeys lasting decades or centuries, spacecraft would face constant bombardment from invisible threats. Cosmic rays alone can damage DNA, destroy electronics, and slowly poison living organisms. The deeper you travel into space, the more hostile reality becomes. Then there is the expansion of the universe itself. Galaxies are not sitting still. Space itself is stretching. The farther galaxies are from us, the faster they move away. This is not because they are flying through space like rockets, but because the fabric of space is expanding between everything. That means the universe is slowly isolating galaxies from one another. Some distant galaxies are already receding faster than light due to cosmic expansion, placing them forever beyond our reach. Even if humanity survived for millions of years and built extraordinary technology, parts of the universe would still remain permanently inaccessible. VV H D. That equation describes one of the most unsettling discoveries in cosmology. The velocity of distant galaxies increases with distance itself. The universe is not becoming more connected over time. It is becoming more divided. Future civilizations may look into the sky and see fewer galaxies than we see today because cosmic expansion will eventually push them beyond visibility. The cosmos is slowly erasing its own structure. Communication creates another impossible obstacle. Suppose humanity somehow established colonies across thousands of star systems. A message sent from one side of the civilization to the other could take thousands or even millions of years to arrive. Governments would collapse under communication delays. Cultures would drift apart into completely separate species of thought. A colony facing disaster could send a distress signal and become extinct long before help arrived. In practice, every interstellar colony would become isolated forever. This creates a hidden paradox. Colonization sounds like expansion, but physics turns it into fragmentation. Instead of one galaxy-wide civilization, the laws of space would produce countless disconnected islands of humanity, each trapped by light speed limits and time delays. Empires cannot function when communication itself requires centuries. There is also the terrifying issue of sustainability. A spacecraft traveling between stars must carry ecosystems, energy systems, medicine, food production, and genetic stability for generations. One tiny failure inside a closed environment could cascade into extinction. On Earth, life survives because of a gigantic planetary support system involving oceans, atmosphere, magnetic fields, gravity, and sunlight. Space offers none of these protections naturally. Colonizing another world is not like building a city in a desert. It is like carrying an entire planet on your back while crossing an endless abyss. And perhaps the most disturbing possibility is that every advanced civilization in the universe eventually discovers this same hidden law. They realize galaxies are simply too large, energy costs too extreme, time too distorted, and cosmic expansion too powerful. Maybe intelligent life survives only by retreating inward, focusing on virtual realities, artificial worlds, or local star systems instead of galactic empires. The silence of the cosmos may not mean civilizations never existed. It may mean the universe itself prevents them from spreading far enough to ever meet one another. So, after traveling through all these ideas, we arrive at a strange and uncomfortable realization. The universe does not appear to be a simple empty stage waiting for intelligent life to spread across it. Instead, it behaves more like a tightly governed system, where every attempt to expand outward runs into invisible barriers. The speed of light sets a hard ceiling on movement. Energy demands grow beyond planetary limits. Time begins to fracture between travelers and those who stay behind, and even empty space reveals itself as a field filled with danger, radiation, and constant risk. On top of that, the expansion of the universe quietly pushes galaxies away from one another, ensuring that even if we dream of a cosmic civilization, the structure of reality keeps pulling it apart. What this ultimately suggests is not just that interstellar or galactic colonization is difficult, but that it may be fundamentally self-limiting. The deeper intelligence reaches into space, the more it discovers that distance is not just distance, time is not just time, and energy is not just energy. They are all interconnected rules, woven together in a way that seems to resist permanent, unified expansion. Instead of a single empire stretching across galaxies, the universe may naturally favor isolation, fragmentation, and separation. But this is not necessarily a message of defeat. It is also a reminder of perspective. Perhaps the value of intelligence is not measured by how far it spreads across space, but by how deeply it understands the small region it is given. Maybe the true achievement is not conquering galaxies, but learning to exist meaningfully within the narrow window the universe allows. And so we are left with a choice in how we interpret this cosmic limit, as a wall or as a direction, as a prison or as a design that pushes us to think differently about progress itself. Good luck to you and to your journey of understanding these mysteries. Thank you for listening.